Okay, so we're going to talk about measures of central tendency, and they can be used to describe an average value in a set of data. The mean and median give a sense of the center of the data set. The mean is calculating the average by adding the data and dividing by the number of data that you have. So a lot of times we see it as x bar is equal to the summation of the x, so that just means we're going to add all the x values together, and then we're going to divide by the number of x's that we have, or the number of data points. Sometimes we might see outliers. Those are going to be extreme scores in a data set. You must decide what you're going to do with them. Sometimes you're going to discard them. Sometimes you'll use another measure other than mean. The median describes the middle of a data set. So think about the strip in the middle of the road. That's the median that goes down the center. So that's what we're looking at here. It's this very center data in the middle of the set. To compute the median for odd number of values of data, we're going to take the median is going to be the middle position. For an even number of values, the median is going to be the mean of the two middle values. So if you have like 6 data values, you're going to take the 2 in the middle of your data set, add them together, just like we found for the mean, and then we'll divide by 2. So the median is not affected by a few outliers. We often want to know which data value occurs the most frequently in a data set. And for example, for fashion designers, they might want to know the most common dress size. For automakers, might want to know the most common height of U.S. drivers. And that is referred to as our mode. The mode of a set of data is the data value that occurs most frequently. There can be more than one mode per data set. Mode can be computed for qualitative data such as eye color, political affiliation, or college majors. The mean and median are not appropriate for such data. So to compare measures of central tendency for a set of data, the mean, median, and mode are usually not the same. You may want to emphasize one measure over another. The 3 measures are often different, so it's up to you to decide how to summarize your data. If you're considering the mean, remember that 1 or 2 extreme values in a distribution have an undue influence on the mean. That's why, for example, in scoring ice skating at the Olympics, the highest and lowest scores are discarded. And let's go into, should be example 1. It'll be example 1 on your handout. I forgot to change these. All right, so for example 1, or I grabbed the old one, we are going to find the mean, median, and mode for the set of data. So we've got a list of numbers, which are our data. So this will be example 1. So we've got, if we're finding the mean, then the median, and then the mode. So for the mean, which is equal to the average, we're going to add all of our numbers together. So we have 1 plus 1 plus 1 plus 4 plus 5. We've got 5, 1, 2, 3, 4, 5, 6 times. 2, 3, yep. 1, 2, 3, 4, 5, and 6 times. Looks like my pen is dying, so let's switch colors here. All right. Now we're going to divide that by the number that we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. Let's make sure we have all 10 in our math. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So we're going to divide by 10. We're going to add these all together. And when we add them, we're going to get 37. Divide by 10, and that'll get us 3.7. And we're going to use our calculator to figure that out. We can use calculator, add. You want to make sure you sum everything first, then divide. That way you don't make any mistakes. Because if you don't put that all in the top first and then hit enter so that you can get the 37, otherwise you have to put the parentheses there, because I've had students do this. They add all of this up, plus 5, and then hit divide by 10 before they hit enter to find that total at the top, and then they get plus 5 divided by 10, which would be a half. So make sure you're actually doing the whole top first, then divide by the 10. All right, and that would be our mean. Okay, let's find the median. The median is going to be our middle number. So, we've got a list of numbers here. We need to find the middle. I'm going to rewrite the list, because what if we didn't have the list in numerical order? On the problem, I gave it to you in numerical order, but what if we didn't have it that way? You want to make sure you put it in numerical order. So we have 3 ones, a 4, and we have 6 5s. So, in this case, I'm going to count in. So we've got 1, 2, 3, 4, 5. I've got 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. These are my 2 middle numbers. Because we have 10 numbers, we have an even set. So what we're going to do is take our 5 plus 5 and divide by 2, which will get us 10 divided by 2, which equals 5. It will not always equal the number that we have, but because they are the same number, we're going to get exactly what we put in there. So that's our median. And now we need to look for our mode. The mode is what happens most often. In our list of numbers, we have 3 1s, 1 4, and 6 5s. So our mode is going to also be 5, because that's the one that happens most often. All right, so let's look at example 2, not example 8. Your handout will have example 2 on it. We're going to find the mean, median, and or mode of the car color, whichever is applicable. Now remember, I talked about on the handout that the mean is not suitable for qualitative attributes that are not numerical. The median is not suitable for qualitative attributes either, but the mode would be. These, yes, there are numbers here, but what we're talking about is car color. Car color is a qualitative. It's the quality. It's like eye color, the car color. It would be, again, was mentioned political affiliation, maybe your college major. So things that are a qualitative thing, not a quantitative. It's not a list of numbers. There is a number that counted how many, but because we're looking at this, we are going to find that for example 2, we are going to look at mode. The mode is the thing that, for qualitative, what happens most often. So if I look at my numbers, my highest one is blue. So for the mode, it's going to be blue. And that means we've got 3,333 preferred it. So the mode is blue. Okay. All right. Our next example is going to be example 3. And on example 3, which single measure of central tendency, which is your mean, median, or mode, would you say best describes the following measurements? All right, so we don't have qualitative here. We actually have measurements, so we can find the mean, the median, and the mode. All right, so example 3. First thing we're going to do is find our mean. Remember, the mean is the average, so we're going to add them all together. We have decimal points. If there's just double zeros, I'm just going to write 7. 6.90, I'll just write 6.9. I would write the 0 if it was like a 0.9 or 0.2 or something like that. All right, so we have 7 plus 6.9 plus 8.5 plus 6.8 plus 7.2 plus 7.23 plus 8.15 plus 7.82 plus 6.8 plus 83. Now, let's make sure we have all of our numbers. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I always want to make sure I didn't leave one off. So that means we're going to divide by 10. When I add the top, I get 149.4 divided by 10, which will get us 14.94. I'm going to go to 2 decimal places because my original part was in 2 decimal places. The question is, does it matter which way I add these? Do I have to add them across, or can I go up and down? It doesn't matter. You're just summing them up, so it doesn't matter which way you do that. All right, let's go look at median. So that's mean. So for median, remember, we have to put the numbers in numerical order. So that means I have to put all the numbers in numerical order in order to do this. All right, so I had 2 6.8s, and then I have a 6.9, a 7, a 7.2, a 7.23, a 7.82, an 8.15, an 8.5, and an 83. So again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I've got them all listed. Now we had 10 on the previous problem, so I know, if I remember, I'm going to go 5 in this way and 5 in that way. So 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So I have these 2 numbers here. So my median will be equal to 7.2 plus 7.23, because these are the 2 middle numbers, and then I'm going to divide by 2. That gets me 14.43 divided by 2 is 7.22. So at this point, let's talk about, we have an outlier here. If you noticed, we have a range of numbers between 6.8 and 8.5. And then we have an 83. 83 is way away from all the rest of them, so that's what we call an outlier. I'm going to make a little note here. This is what we call an outlier. It lies outside of the regular values. Those are all pretty close together. This one's way huge. So if we look at the median is 7.22, but our mean is 14.94, it's twice as much. So this one up here, this was influenced by the outlier. This one is not affected. By our outlier, because it's in the middle between these numbers. If you look at this one, between 6.8 and 8.5 should be your mean, but it's actually way outside of 8.5. So most of your numbers are up between 6.8 and 8.5, but the mean or the average says it's way above that. That's how we know that's influenced by it. This one, our median is still in the middle of our numbers, so So that's why we say it's not affected by it. All right, now on the last problem on median, we actually put all of our numbers in numerical order. So now we can look for any repeats to find our mode. So we have two 6.8s, and I don't see any other repeaters. So our mode is going to be 6.8 because that's the one that happened the most often. Again, the mode is not affected. By our outlier. However, if we look at our mode, the mode is 6.8. That is at the very end of our data set. Our mode is not somewhere in the middle. It's at the very first number that starts our list. So because we're looking at that, it's probably not going to be our best choice because it's at the end of the data set. So I would say that the median is the best, another die and pen, is the best measure of central tendency. For the data set. So the median is going to be our best choice for the measure of our central tendency on this data set because it's not just the low end, it's not above most of the numbers, it's right in the middle. All right. And our next example is example 4. And here we have find the mean, median, and mode for the data in the table. So we have price-earning ratios for 8 stocks in a portfolio. So here's our list of stocks. So we're going to find our mean, which is the average, the median, which is the middle, and our mode for the data in the table. All right, so let's find our mean first. So for the mean, I'm just going to add them all together. So we have 6.9 plus 10 plus 19.4 plus 31.8 plus 12.9 plus 8.8 plus 10 plus 15.9. All right, so we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I didn't leave anybody off. And that also means I'm going to divide by 8. When I add those on a calculator, I'm going to get 115.7 divided by our 8 will get us 14.46. So there is our mean. Okay, let's go find the median. Again, remember that in the median, they have to be listed in numerical order. So we're going to have 6.9, 8.8, 10, 10, 12.9, 15.9, 19.4, and 31.8. 1, 2, 3, 4, 5, 6, 7, 8. So half of 8 is 4, so I'm most likely going to count in 4 from each side. So 1, 2, 3, 4. 1, 2, 3, 4. So my median is going to come from those two numbers. So we are going to find the median is equal to 10 plus 12.9 divided by 2. Now, if we had an odd number like 9, it would be the middle number between them. These just examples all seem to have all even sets. All right, so on the top, when we add that, we get 22.9 divided by 2 will get us 11.45. And then our last thing that we need to do is find the mode. And again, the mode is the one that happens most often. That's a single, oh, we have 2 10s. That's one number, so it's going to be equal to 10. 10 is the only one that repeats. So here we found the mean, median, and mode. We weren't asked anything of deciding which one's best or anything, and that's just how we do it.